Okay, everybody, this is 8.5C, the 30th problem there, so it's towards the end, and I'm just going to go through it. I'm going to go a little bit more quickly than last time, but obviously this is YouTube, so if you want to pause it and go back, you can, and pick up what might not have been obvious the first time. So again, like some of the others that we've taken a look at, first thing you want to notice is what kind of proof is this? The conclusion is a conditional. So that means that we are going to set it up the same way we do every conditional proof. We know there's going to be a conditional proof. There's a conditional right there. We want to assume this part, left side, the antecedent, and we want to get to that part. And then our conclusion, our last line is obviously going to be this right here. All right, so let's set it up. We know that we want to assume the antecedent, and that is D and I. So that's what we're assuming. All right, so let's say assume right there. And what you can do, which I suggest, is putting the conclusion as the last line. So let's go ahead and do that. If D and I, then not F. There's our goal. There's where we want to go. It's this condition. And we know that the second to last line is going to be also in that conditional proof. We don't know what number it is, but we're just going to put the last thing that we want, and that's not F, right? That's the consequent, the right side of this conditional. That's what we want. Actually, here, let's go down here. We can say a bit more. We can say that we started this conditional proof at line 3 to don't know. I'm going to leave that blank, comma, and we use CP. We know that much. Okay, so we don't exactly know what this is going to be, but we know that if we assume D and I, we need to get not F, that consequent. Okay, so you're probably seeing what I'm seeing right now. I hope you are. You're seeing right now, let's talk through the strategy. You're seeing D and you're seeing I. You know that we can simplify to get D and also simplify to get I from this same line. If we get D, then we get this whole thing right here. If we get I, then we get this whole thing right here. And that's going to give us more to work with. So let's go ahead and do that. I say a lot that if you have a conjunction there and you want the parts of it, the conjuncts, then right away just go ahead and simplify that. So let's do that. Let's do left side first. We're going to get D out of 3, and we use 3, and we use the rule of simplification. Okay, so far so good. Then our next line, let's get I. We have I, we use that same line and same rule. All right, so now that we have D, now that we have I, we can then, you should see right away, we can do modus ponens on 1 and on 2. So let's go ahead and do that. First things first, line 6, let's go ahead and do that first line. So if we have D, if we have D and we also have if D, then that whole thing, then we can get the consequent. Okay, so we have E or if E or F, then G and H, G and H. And we got that using line 1 and line 4 modus ponens. Okay, so let's just go ahead and do that to the other side. This is the easy part. You should see this. This isn't applying any crazy rule or anything like that. It's pretty rote at this point. So let's do that to line number 2. We have H or J. If that, then parentheses K and not F. And the lines that we used were 2 and 5, and same rule, modus ponens. Okay, now we got to step back a bit because here's where we want to go. We want to go to this not F, which means we're gonna find it. How are we gonna find that? I am not seeing a clear way with what we have so far to get not F. So when we're not seeing it right away, what can we do? Well, we've talked about this. We even did one in lab. Let's try an RAA proof. And to do that, we are already in an assumption. Remember, we're already in that CP. And we're going to assume something else. So if we do that, we have to put another bar here to tell WebTutor this is an assumption within an assumption. Another way to say it is a subproof within a subproof. All right, so this is our 8th line, and we're going to assume the negation of where we want to go in this conditional proof. And the negation of where we want to go is not F. All right, so I'm going to assume not F and hope that we get a contradiction. That's what RAA is. I'm assuming the negation of this, and I'm going to derive a contradiction. I don't see how I'm going to do that quite yet, let's say, but I'm hoping that we can do that if I use RAA. And like we said in class, RAA works every time. It's just a question of whether it's the quickest way to get there or not. So again, not F, because right here I'm assuming the opposite, and I'm assuming that. So I write assume. Okay, we're still under that RAA, so I keep the 2 vertical lines right there. Now, I want to get that F by itself. So there's F, because I know, because I've been practicing, that not F is the same as F using what rule? 8 and the double negation rule. You know, you can just say that F is the same as not F, not F is the same thing as F. That's the double negation equivalence rule. Okay, so now we have F. All right, so we're still under that RAA, and remember, we want to get a contradiction. And so, again, I don't know exactly how I'm going to do that yet, but I'm just going to apply some rules and hope that the contradiction appears to me and looks pretty obvious once I applied a couple rules. So I have F, I see F up here, and immediately here's an or and something else, and I know that I can just add that. I can add E to F, right, using or F. So I have F, I can just write F or E using addition. So let's do that, F or E. And if I have that left side, I can get the right side using modus ponens. We already used that rule, so that should be familiar at this point. F or E, and I used line 9 because I already had F, and then I just added or E. That's what the addition rule says. So make sure if you're not familiar with that you're looking at that rules page and knowing exactly what I'm doing at this point. Nothing is that complicated so far. All right, so if I have F or E, you know what? Let me go back. I'm going to do this, E or F. You may have noticed that, so good job if you did. I'm gonna write it in the order that it is here, all right? It allows you, if you have F, to put it on either side, that addition rule. You can put it on this side or this side. I want it on this side because here is the antecedent right here. That's what I want to get this over here. All right, so next line, still under that RAA, so I get double lines. And if I have line 10 and if I have line 6, I get G and H. And I used, again, line 6 and line 10 and the modus ponens rule to get G and H. Okay, and now it's a lot easier to see where I'm going to go. If you see it, let me just point it out. Okay, here, it didn't take me that many steps to see how I'm going to get a contradiction. All right, so I got this, and now I have G and H. I know that if I do something similar to what I just did, which is I'm going to simplify H out of here, I'm going to add or J to it, and once I get that, I can get this side over here, the consequent, and I see a not F right there. That not F is going to be useful because it contradicts this F right here. And if it contradicts, then I have my sub goal here, and if I have my sub goal, I have my main goal here. That's how I'm thinking of it right now. So basically, it's just going through the motions at this point. I already know where I want to go. I need to get that not F by itself to contradict this, and get that and get that. If that's too fast, then watch it again and see how I reason through that. And keep watching because you'll see me just work it out, and I'll try to explain it as I go. So I'm going to get H right here from line 11 using what rule? Simplification, obviously. 11 and simplification. And the next line, I'm just going to do something similar to what I did before. I have an H. I can just write H or J using addition. H or J, because I'm just using addition on line 12. 12, addition. And I do that because if I have H or J, I didn't need to swap anything at that point. If I have H or J, then I can get this, right? I can get this, and that's what I'm going to get. I'm going to apply modus ponens and get K and not F, and I used lines 7 and 13 and the modus ponens rule. Now I have K and not F. Hopefully you see where I'm going now. Line 15, I'm still in that RAA. I'm still trying to derive a contradiction so that I can prove the negation of this, which is this, just as a reminder. So I'm going to simplify not F out of there. Not F, and that's from line 14, and I just use simplification again. So look, this looks like a complicated proof, but it's really not. All I've been using is simplification, modus ponens. I assumed the opposite of where I wanted to go. I used double negation. That's easy. I had to add a couple times. Simplify, modus ponens, simplify. There aren't too many complicated rules that I've used so far. So look, I get not F, and I have F up there. So my last step always on an RAA proof is a contradiction. And I get that by F and not F, which is lines 9 and 15 using the rule conjunction. Remember, conjunction just says if I have a line up here and I have a line here, I can put them together. Just conjoin them, right? Right there. So there's my contradiction, and that's the last line of my RAA proof. That's the last line because, again, what I was assuming is the negation of what I wanted, and if I derive a contradiction, I know that the negation of this is actually true. So that's how RAA proofs work. So this is going to be the last line. And so my next line is actually going to be this line that I have already put down. I didn't know at the time that it was line 17, but now I do. Line 17, and that is in the conditional proof, right? I got not F because I assumed this and got the opposite of it. And I say that I did that. Here's the start of my RAA assumption, line 8 through the line right above it, 16. And I used RAA. And now that I did that, right, here's our CP assumption. Way back here in line 3, this was what I assumed, this side right here. And I got the consequent, not F, right here through RAA. So if I assumed this, if DNI, then not F, then that's exactly what I can put here. Line 18 says, after I do all this, this spits out from this long conditional proof here, 3 through 17. All right, and hopefully I didn't make any mistakes there. Let's check it, and we're good to go. And that's how you do a conditional proof, which you already know, and an RAA proof, which doesn't necessarily have to start right after the CP assumption, right? We didn't start the RAA proof right here in line 4. We started it down here in line 8 because we basically did a few things right here, got stuck, went to RAA. You can always do that. So hopefully that's helpful in allowing you to figure out the strategy and some of the details in doing those sorts of proofs, a proof within a proof.